Welcome to section 7.4, day 2, multiplying radical expressions. Today's objective is to simplify products and quotients of radical expressions. So when multiplying radicals, we use the distributive property, we multiply the coefficients, and then we multiply the radicands. And then we simplify if needed. So as long as we're just dealing with square roots or cubed roots, this is how we go about it. So here we have the square root of 2 times the square root of 14. They're both square roots. So we can multiply the coefficients together. In this case, the coefficients of each of these are 1. And then we multiply what's underneath the radicals together. And we have 2 and 14. So when we multiply these together, we get the square root of 28. Now we need to see if we can simplify this. Can we pull out a perfect square? And we can. We have the square root of 4. Is a perfect square we can divide out to 28. So we end up with the square root of 4 and the square root of 7. We simplify the square root of 4 and we get 2 square roots of 7. And this is my simplified form. So the next time we have the 3 square root of 6 times 4 square root of 2. We're going to multiply the two coefficients together. So we have 3 times 4, which is 12. Then we have the radicals, square root of 6, square root of 2. We multiply their radicands together, we get the square root of 12. And again, we need to see if we can simplify the square root of 12. And we can. Again, we can pull the square root of 4 out. And then the square root of 4 is 2. So we have 12 times 2, square roots of 3, which is 24 square roots of 3. And the last one, we have 5 square root of 3, multiply the parentheses, 2 square roots of 3 minus the square root of 7. Here we multiply in to both, we distribute completely. And we have 5 square root of 3 times 2 square root of 3. We have 5 times 2, which is 10. The square root of 3 times the square root of 3. Multiply the radicands together, you get square root of 9. And then we have 5 square root of 3 times negative square root of 7. This is technically a negative 1 out front, so 5 times negative 1 is negative 5. Square root of 3 times the square root of 7 is the square root of 21. We look to see if we can pull any perfect squares out. Well, 9 is a perfect square, so we'll be able to simplify that. 21 does not have any perfect squares that divide into it evenly, so it's already simplified. But we do have to take 10 square roots of 9, which is 10 times 3. And we have the minus 5 square roots of 21 coming up. And then 10 times 3 is 30. So 30 minus 5 square root of 21. One thing I hope you have noticed is that yesterday when we were doing adding and subtracting, we had to have like radicals. When we multiply or divide, we do not have to have like radicals. We can multiply different radicands together and then simplify. That is the biggest difference between adding and subtracting and multiplying and dividing. Adding and subtracting, you must have like radicals. For multiplying and dividing, it does not matter as long as we're just dealing with square roots or just dealing with cubed roots. We are only going to work with square roots with this year. So here we have simplify the products. We are going to distribute. So we have the square root of 3 times 2 square roots of 5. This is 2 times the square root of 15, because 5 times 3 is 15. Plus, square root of 3 times the square root of 3 is the square root of 9. We cannot simplify square root of 15. There are no perfect squares that we can divide out. And so we have 2 square roots of 15. The square root of 9 is 3. This is my simplified form. Next, we have negative square root of 8 multiplied by 2 minus 3 square roots of 6. Again, we must distribute. And we have negative times 2, so we have negative 2 square roots of 8. Negative times negative 3 is a positive 3, so plus 3. And 8 times 6 is 48. Now we need to go through and see if we can simplify either of these radicals. And for the first one, we can pull out a perfect square of 4. So we have negative 2 square roots of 4 square roots of 2 plus 3. And the largest perfect square we can pull out of 48 is 16. And here's the square root of 3. And then we simplify our perfect square. So we have negative 2 times 2, square root of 2, plus 3 times 4. Square root of 16 is 4. Square root of 3. And this becomes negative 2 times 2 is negative 4. Square root of 2. 3 times 4 is 12. So plus 12 square roots of 3. And this is my simplified form. All right, and then the last one, we are going to distribute in again. So we have 3 square roots of 5 multiplied by 2 square roots of 5 plus 5 square roots of 3. So again, we take 3 times 2, we get 6. Square root of 5 times square root of 5 is the square root of 25. We have 3 times 5, which is 15 for our next term. And then square root of 5 times the square root of 3 is the square root of 15. And then we simplify our radicals. Square root of 25 is just 5. So we have 6 times 5. And then we have 15 square roots of 15. And we can just multiply 6 times 5 together. We get 30 plus 15 square roots of 15. And this is my simplified radical form. So one of the things you might have noticed as we went through this, when we had the square root of 5 times the square root of 5, you might have noticed that when we simplified this out, we got back 5. When we have 2 of the same square roots multiplied together, we get back the radicand because we have 2 of them. And if you think about it, if we wrote these as rational exponents, we'd have 5 to the 1/2 times 5 to the 1/2. And 1/2 and 1/2, when you add them together using our property of exponents, we'd have 5 to the 1st, which is just 5. So if you recognize this, it will save you some steps. If not, go through the whole process. You'll still get the same answer. So the quotient property of square roots, I touched on this briefly in 7.3. So it says here, for any real numbers a and b, where a is greater than or equal to 0 and b is greater than 0, the square root of a over b is equal to the square root of a divided by the square root of b. So what we have here is the square root of a over b is the same as, we split that radical up across the division bar, and we get the square root of a over the square root of b. So a number demonstration of this is if we had the square root of 16 over 25, we can break this into the square root of 16 over the square root of 25, which is 4/5. And again, when we're doing this, if you start with a fraction, we end with a fraction. So if we have the square root of 81 over the square root of 100, we can break the radical up across the division bar. Just like we broke it across multiplication, we can break it up across the division bar. So we're left with square root of 81 over the square root of 100. These are both perfect squares. Square root of 81 is 9. The square root of 100 is 10. And we get 9/10. For the next one, we have 7 square roots of 8 over the square root of 49. It's already split up. We can take the square roots of both of these. Square root of 8 is not a perfect square, but we can break it into a perfect square, which is the square root of 4 times the square root of 2, all over. And I'm just going to simplify this right away. The square root of 49 is 7. We go to the next step. We have a 7 over a 7. These will cancel out. The square root of 4 is 2. And we have the radical 2 left. So we have 2 square root of 2. The last one we have the square root of 32 over t to the 4th. We are going to split this up into the square root of 32 over the square root of t to the 4th. And we want to break the square root of 32 down. The largest perfect square that goes into 32 is 16. So we have the square root of 16 and the square root of 2. And square root of t to the 4th, we have an even power on our variable t. This becomes t squared when we take the square root. And then we get 4, because the square root of 16 is 4. Square root of 2 over t squared. And that is my simplified radical form. So again, when we have a square root over a fraction, we can take the square root and split it up across the fraction bar. So rationalizing the denominator. So one of those things you learned yesterday is that we cannot have radicals in the denominator. So today we're going to show you how to get rid of those radicals in our denominators. So to rationalize the denominator, we multiply the numerator and denominator by the simplified radical in the denominator. So what does this all mean? Let's look at the first one. We're going to break this radical over the division bar. So we have the square root of 5 over the square root of 2. Now we cannot simplify either of these radicals. They're both prime numbers. There's no perfect squares we can pull out of them to simplify. So what we have to do now is we can't have that radical in the denominator. So we multiply both the numerator and the denominator by the radical from the denominator. Remember, we've done this before for getting common denominators. If we're multiplying by the square root of 2 over the square root of 2, it's like multiplying by 1. So then what we get is we have the square root of 5 times the square root of 2, which is the square root of 10. Then we have the square root of 2 times the square root of 2, which is the square root of 4. And the whole purpose of doing this is to get rid of radicals in the denominator. And when you take the square root of 4, you get 2. So now we have square root of 10 over 2. And that is my simplified radical form. We have rationalized the denominator. The denominator now has a rational number in it. And like I said earlier, if you recognize that the square root of 2 times the square root of 2 is 2, you can go right to this point right here. You don't need to do that intermediate step. So now we have the square root of 35 over the square root of 15. The first thing you should always do is look at these fractions and can we simplify them before we do anything else. And between 35 and 15, they are both divisible by 5. So this is the same as the square root of 7 over 3. And now I'm going to split my radical up between the numerator and denominator, break it up over the division bar, and now we have the square root of 7 over the square root of 3. From here, we want to rationalize the denominator, so we multiply by the square root of 3. And when we do this, we get the square root of 21 over the square root of 9. And like I said previous, if you understand how this works, it just becomes the square root of 21, and the square root of 9 is 3. And if you understand this piece right here, we can go right to the final answer of the square root of 21 over 3. All right, last one we have is the square root of 3n over the square root of 8. And again, before we do rationalize the denominator, we want to simplify if we can. Well, the square root of 3n cannot be simplified. We cannot pull out any perfect squares out of 3 or n, but we can simplify the square root of 8. And we can break that into the square root of 4 times the square root of 2. And when we do this, we get the square root of 3n over 2 square roots of 2. So the square root of 4 is 2. From here, now we have a simplified radical. We want to get rid of the radical in the denominator. We want to rationalize it. So we are going to multiply by the square root of 2. And when we do that, we get the square root of 6n. Like I said before, we have the square root of 2 and the square root of 2. Well, the square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is 2. So we have 2 from here times, and I guess I'll write it all out, the square root of 4. But like I said previous, if you understand how this works, this is the square root of 6n over 2 times 2, which is the square root of 6n over 4. And this is my simplified radical form. So what you should do with these is see if you can simplify your fraction first, then see if you can simplify the denominator at all with your radicals, because it will save you steps if you can simplify it first. And that is how we go about rationalizing the denominator. Here we have 3 more. I would like you to try number 1 and number 2. So pause the video, try to simplify them, and then see if you get the same answer I do. For number 1, we should split the radical up first. There's no way to simplify 16 over 63, but we can break the radical up to get the square root of 16 over the square root of 63. And we want to simplify our radicals if we can. The square root of 16 is 4. The square root of 63 we can break into the square root of 9 times the square root of 7. And this becomes 4 over square root of 9 is 3. So we get 4 over 3 square root 7. Then we can multiply the top and bottom by the radical in the denominator. So we're going to multiply by the square root of 7. And we get 4 square roots of 7 over 3 square root of 49. And again, if you recognize that the square root of 7 times the square root of 7 is 7, you could go right to 4 square root of 7 over 3 times 7, which is 4 square roots of 7 over 21, which is my final simplified form. 4 square root 7 over 21. For the next one, we have 3 square roots of 36, and we have the square root of 72. There's a couple of different ways to approach this. One is I'm going to leave it as square root of 36 on the top in the numerator because I recognize that I can break the denominator into the square root of 36 and the square root of 2. When I do this, I now have the square root of 36 in both the numerator and the denominator, so I can cancel them out, leaving me just 3 over the square root of 2. Now I can rationalize the denominator, and this is the square root of 2 times the square root of 2. All right. We rationalize the denominator, we get 3 square roots of 2. And if you recognize, again, we're multiplying the square root of 2 times the square root of 2, which becomes the square root of 4, which is just 2. So we have 3 square roots of 2 over 2. My square root symbol there is a little messed up, but it's 3 square root of 2 over 2. For number 3, we're going to break the radical up into our numerator and denominator. So we're going to break it across the division bar. So we get the square root of 7 over the square root of 3t cubed. And then we're going to see if we can simplify this. The square root of 7 cannot be simplified. But the bottom, we can break this into the square root of t squared and the square root of 3t. And then from here, we get the square root of 7 over t square root 3t. Once we can't simplify it any further, we're going to rationalize our denominator. We're going to multiply both the numerator and denominator by the square root of 3t. And when we do this, in the numerator we get the square root of 21t. On the bottom we had, the denominator we had t, and then the square root of 3t times the square root of 3t is just 3t. You would get 9t squared, and then the square root of 9t squared is 3t. From here we get the square root of 21t all over 3t squared. And this is my simplified radical form. So all right, that's it for 7.4-day-2. Today we simplified products and quotients of radical expressions, and then we rationalized the denominator. Thank you for watching, and have a nice day.